All right, ladies and gentlemen, welcome back to the Super Bowl halftime show, I guess, of mathematics. This is Resh Mahaber once again signing on for Math 1800 at Wayne State University. And we're just finishing up the back end of what to do when we have higher order polynomials, right? So this is still the discussion of what do we do when we have big stuff. So I'm going to give you an example of a guy in the past. That is quote unquote fun. And what I mean by fun is that it's a little dirtier. And we covered a couple things ever since we started this entire discussion. So let's just do a quick overhaul and make sure we understand the great trifecta. Okay, so there was something we got called the factor theorem. Okay, and this all lies together. So here's the idea: if I have a root, which means that it's a solution, right? Then that means I can add and subtract the piece over and get a factor. Now, what would I use the factor for? If you're a factor, then that means that you can now use this factor to divide into the polynomial that it goes into, and then use that to solve. No, so this is kind of the train of thought that you're using when it comes to stuff like this. So, for example, let's go ahead and do one just so we recall what this means. So let's say I said solve, and I'm going to say solve this thing, x cubed minus 12x minus 16 equals 0, given that 4 is a root. Well, good news. If 4 is a root, okay, so here's the solution. If 4 is a root, then that means subtract that over, x minus 4 is a factor. And if it's a factor, then that means x cubed minus 12x minus 6, that this x minus 4 should go in evenly, right, into that. And you should have some stuff that goes here. Well, how I figure out what that stuff is I need to go to the side and long divide x minus 4 into x cubed minus 12x minus 16. It is really that stinking simple. So now, hopefully you guys are great at long dividing. This goes in x squared times, so it gives you x cubed minus 4x squared, and then you distribute your negative in. This drops. Now note, none of this adds together because it's x squared, that's x's, that's negative 16s. So once again, in order to do this, your long division for sure has to be strong. X goes into 4x squared how many times? Well, 4x times. So that's 4x squared minus 16x. Subtract it off. And once again, if it goes in evenly, if this is true, then it goes in evenly, right? We won't have anything left over. So then x goes into 4x 4 times. 4x minus 16, distribute a negative in, boom, boom, it went in evenly. So what does this tell me? My question mark stuff is going to be this. So let's get rid of these question marks. And this lets me know that this thing now goes in here, and that thing is x squared plus 4x plus 4. All right, time to rock and roll. And now, if this thing doesn't factor, I can quadratic it. Once again, we're always trying to get down to a degree 2 because we have quadratic formula always to rely on. Now, if we have a degree 3, then we might have to keep doing this division thing over and over and over again, pending the factors that we have. All right. So this gives me x plus 2, x plus 2. Look, it's a multiplicity of 2, duplicate roots. So x equals 4 and x equals negative 2 are our solutions. Isn't that pretty simple, right? But notice what was the catalyst behind this entire problem was the fact that we knew this, right? We knew that given that 4 is a root. So here's a question. What the heck do we do if we're not given a factor? What if they don't give us this? Then all this work that we have here that's based off of this is pointless. We don't have a root, hence we don't have a factor, hence we don't have a factor that can long divide in to get this other piece, hence we can't stick this back in, hence we can't factor it, and hence we can't fit it all out. So all this work is null and void. So basically, factor theorem only works if they give you a root, a factor, or a solution. So we didn't give you that. So none of this works. So what in the world do we do? Now, no, we already know what the answer is to this. Like, it's not going to change just because I change it differently. So let's get rid of this and work the same problem and see how we figure it out. So this is going to be, let me just rewrite the same problem down here. So we're going to do x cubed minus 12x minus 16 equals 0. Okay? And our job is to solve this. Now, we already know what the solutions are, but this is how this is kind of going to work, okay? So we have a backup plan, and this is what the backup plan is called. So we don't have a factor, so you need to be gritting your teeth because this is about to be a lot of work. Okay, this is called the rational root theorem. The rational root theorem. Now note, this is called the rational root theorem. Anybody know what rational means? It means fractions. Whole numbers are also fractions, so that's included in there. So we have a slight issue with this. Let's say your roots were not rational. Let's say they were irrational or imaginary. You would not be able to find them with these. And yes, there are problems where all the roots are imaginary and it's just not possible to figure out what they are. Like, for example, if I said x squared plus 1 equals 0 and solve that, you couldn't use the rational root theorem because his solutions are plus or minus I. Okay, how did I get that? X squared equals negative 1, square root of sides, plus or minus I. So rational root theorem would not work. Okay, so what this theorem does, it allows you, hopefully, to prospectively find one, maybe two rational roots, maybe one rational root that you can long divide in. So it can basically, it's a way of accruing this piece of information. So you're finding this piece of information first, so then you can start this whole chain of events so the problem falls apart. That's kind of the idea. So how do we find that piece of information? Well, you need to look at a ratio. Okay, I'm going to call this number in the back P, and there's this number in the front here, this one, that's called Q. Okay, and this is how you kind of do it. And this is what the rational root theorem says. You look at all the factors of P to Q, so that ratio. And if you have a guy that's a solution in there, it'll be from that ratio. Okay, so check this out. So here are all the factors of P. Factors of P. Now note, yes, 1 goes into 16, 2 goes into 16, 4 goes into 16, 8 goes into 16, and 16 goes into 16. But not just those guys. Don't forget, we want the positive and the negative. Okay? Now what are the factors of Q? Well, it's 1. That's it. It's the only thing that goes into 1, right? Since Q is 1, it's the only thing that goes into 1. So to figure out the possible solutions, notice I said possible solutions, are going to be a ratio of all the P's to Q's. So that means you're going to take 1 and divide it by 1, which when you take plus or minus 1 and divide it by 1, you get plus or minus 1 again, right? Well, I'm going to write it all out so you can see it. Plus or minus 2 over plus or minus 1, plus or minus 4 over plus or minus 1. And you can see that this can be really exhausting. And it's all the different options of P to Q. So plus or minus 16 to plus or minus 1. Okay, and what do I say, all the different options? Let's say you had two other guys here, plus or minus 3 and plus or minus 6, because let's say the numerator was the Q here was a 6 instead of a 1. Then you'll have to divide 1/3, 2/3, 4/3, 8/3, 16/3. Those would all be possible zeros. Same thing with 1/6, 2/6, 4/6, 8/6, 16/6, and then you'll have to see if those are possible zeros. Okay, so this can be a very, very long and exhausting and drawn out problem. And if you say, well, no, there's got to be a shorter way, I'm be honest with you. If you have to use rational root theorem, you're easily adding 10 minutes onto any problem. So there's plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and plus or minus 16. These are all the possible roots, right? Now, let's bring you back to factor theorem. Now that we figured out our possible roots, what does factor theorem say? If you have a root, you have a solution. And if you have a solution, you have a factor. So here's the idea. These are the possible solutions. So how do I figure out which one is a solution? Well, since I know, what is my function again? I forgot totally what it is. X cubed minus 12x minus 16. We know p of x is my function, x cubed minus 12x minus 16. If they're a solution, if it's a solution, then what does that mean? If you plug it in here, it should make it equal to 0, right? That's what a solution does, okay? So now let's just get the check in here, okay? So we already know what the answer is because we did our last example. So I'm not going to go through and plug in the answers immediately. That's what I want to do. And I always tell people to check -1 and 1 immediately because they're easy. So let's check 1 first. Okay? You plug in 1, you get 1 minus 12 minus 16. What's the point? It's not 0. No solution there. So let's plug in -1. You get -1 plus 12 minus 16. It's not 0. Doesn't help any. Let's plug in 2. Okay? 2 cubed is 8. All right, I can't do this in my head. This is very tough for me to do. 2 cubed is 8 minus 2 times 12 is 24 minus 16. This is going to, oh, we're close, I think. That gives me negative. Now, I see how I'm getting excited because this is negative 16. It's almost like they got the same line, so this is not it either. So that's not 0. Let's try -2. -2 will give you -8 minus, plus 24 minus 16. Bingo, 0. So good news, because we did all this work, and I'm going to get it away now. Note, I'm a little tired, so computation for me is terrible. So what does this tell me? This tells me that x equals -2 is a solution. And if x equals -2 is a solution, I know that x plus 2 is a factor. Now, don't go through and long divide this in. I mean, don't go through and try to plug in the other solutions to do it. We're just trying to figure out one factor so we can long divide and break it in. Now, check this in. Check this out. If this is x cubed, this is degree 3, and I have a degree 1 here. I divide it in. I'm going to end up with a degree 2, which means I can do quadratic formula. Good to go. So now, I'm going to take my x plus 2. I'll divide it into x cubed minus 12x minus 16. So, you'll see that this is going to be x squared, x cubed. Remember, it should go in evenly, right? Plus 2x squared. Subtract, boom. Negative 2x squared minus 12x minus 16. This is going to be negative 2x. Negative 2x squared minus 4x. And I need to subtract that off again. This gives me 8x minus 16, which gives me positive 8. Which this, I think this works, doesn't it? Uh-oh, I might have screwed up. SpaghettiOs. Where did I screw up at? Minus 16. I copied down wrong? Maybe. And double check. So this is the tough part. When you get a little tired, you'll start making mistakes. And you gotta slow down when that happens. 4x, this should be a minus 8. Haha! I forgot to drop a negative. See that? 12 minus 4 is 8. It's negative. So you get negative 8. Negative 8x. X minus 16. Distribute a negative in. There goes our 0. So this tells me I went through all of this work of just possibly getting P's and Q's. So this last piece of figuring out the factors and P's and Q's to just get that little piece in the beginning where they give me given information. So now I could finally say that x cubed minus 12x minus 16 equals 0 factors into x plus 2 times x squared minus 2x minus 8. And good news, this gives you what? X plus 2. And this thing factors x plus 2, I think, x minus 4, which gives you x equals negative 2 and x equals 4. Now, we just did this entire problem as if we didn't do it in the beginning. Look how much work was required if they gave us that factor. It fell apart almost instantaneously to get the same answer, 4 and negative 2. Now, if they didn't, then we have to use rational root theorem first to actually figure out the possible factors. Then, hope to God we don't make a mistake doing the arithmetic, just to hope one of them gets hit 0 so we can find the solution. And then, once we have a solution, we can use factor theorem to then push us through the entire process to long divide, and then finally factor the last piece. And then here's something that's crazy. If we do this, and let's say this is degree 4, we long divide it to degree 3, we might even have to do factor theorem again. So, moral of the story is, factor theorem is a pain in the neck. Okay? It is good in a bind, but it is not something you want to do immediately. You want to try to factor the problem, or if they give you a factor, use that factor, use factor theorem to long divide in. You don't want to use rational root theorem. I know I keep saying factor theorem, right? But you don't want to use rational root theorem. It's long, exhausting, and a pain in the neck. Factor theorem is okay once they give you a factor, because all you have to do is long divide and push through, which is not bad. Okay, so here's a moral of the story. They give you a factor, smile, because that means you got a whole bunch of stuff to use. They don't give you a factor, life sucks terribly, and hope that you can get to where you need to go without any issues. So here's what I want you to solve for tomorrow. I want you to solve this guy, and yes, I know it's going to hurt, but it's okay. Okay? The guy I want you to use is this guy. Solve x cubed minus 4x squared plus 6x minus 4 equals 0. And I'm not going to give you the factor. Okay, I could tell you what it is, but it'd be no fun. I want you to use first rational root theorem to figure out your possible factors. Then check them by plugging them in. If one hits 0, then you're ready to rock and roll and use factor theorem, which says that you can go ahead and long divide that guy in and rock and roll and break that guy apart. So, once again, this is Resh Mahaber. I was about to say this is rational root theorem signing off. That's so funny. This is Resh Mahaber signing off. Once again, rational root theorem is probably the most exhausting part of 1800, but it's necessary. So you won't use it a whole lot, but it is something that will get you out of a bind. Once again, if you're going to become better than what you are, to do some things you've never done, you're going to have to go places and push beyond your normal means and your normal limits. So keep grinding. Push yourself past your normal study habits, and I will see you on the next video.